Hello guys, so in today's video I'm going to be showing you how to use Terraform. Welcome to my channel. This is Roland Tutorials, and in this video we are going to do a hands-on project on how to use Terraform to do a number of things, and these are the activities we are going to carry out using Terraform to perform these 10 activities. So one thing about DevOps and cloud engineering, there are multiple ways to carry out every task. There are multiple ways to carry out any project, but the only thing you have to look out for and the only thing you have to make sure you do is that you follow standard practice and procedure so that you can avoid any kind of errors or any kind of security breach. So there are many ways. You might have better ideas on how to carry out this project, but just make sure that you're following standard practice and standard procedures. So the requirements that you need is just a little fundamental knowledge of Ansible. I think I should add Ansible here. So Ansible knowledge. Okay. So you're going to need a little knowledge of Ansible. I'm still going to explain Ansible, but I'm not going to go in depth into Ansible. And then you're going to need to install Terraform. I'm going to take you through all this process, how to do the installation. So the first thing we're going to do is we're going to prepare our environment where we will be carrying out the Terraform project. So the first thing you need to do is, if you're using a Windows 10 like I am, because I'm using a Windows, this is Windows 10. So if you're using a Windows 10, the first thing you need to do is to install VS Code. VS Code is a very wonderful text editor. So you are going to install VS Code. It has where you can install extensions, lots of features that you really need for this project. So the first step is to install VS Code. Then after installing VS Code, you need to install the Ubuntu WSL created by Microsoft. So this is it, Ubuntu. So I have it installed. You need to install this. You just go to your software store, the normal Windows software. So just go to Windows Store. Okay. So you just go to your Microsoft Store. When you open this Microsoft Store, you search for Ubuntu. So you see a package like this, then you install this package. There is a process. I made a video on how to install the Ubuntu subsystem on my channel. I'm going to paste the link on this video. So you just follow the link and run the installation. You have to install it properly so you don't run into an error. Follow the video step by step so the Ubuntu subsystem will function properly while you carry out this project. So once you're done installing this Ubuntu subsystem, you're good to go for the next step. So for my own system, I already have it running. So I'm just going to open VS Code, and then I'm going to import the files I'm going to use. So I already created a folder for this project. So I'm just going to add the folder here. The folder is in my GitHub repository, so don't worry about it. I'm going to paste the link for my GitHub repository, so you can just clone my repository and follow me along. Check the comment section, the description box. I'm going to drop my GitHub repository that contains these files. So I'm going to use add files. That's after you have cloned my repo, you just come to add folder to workspace. So I have it in my documents. So I'm going to open Terraform. I have it in Terraform. This is the folder we'll be working with. Terraform backend EC2 Ansible. I'm going to click it and I'm going to say add. So it's been added. These are all the files that you're going to need to carry out all these steps that I mentioned there. We're going to carry out all these steps, and I'm going to explain each step. So just be patient and follow me along. So the first thing let me explain all this file you see here so you don't get confused. I'll start from this file, Ansible CFG. So this Ansible CFG just refers to Ansible configurations, and then all this written in the Ansible configuration file is just settings to just make sure that your Ansible works correctly. You can learn more about this if you just Google Ansible CFG. You will see examples of how these commands are used. So these are the commands that you will need to run this project. You can just use them exactly like this. If you know what you're doing, you can tweak them to fit your own process properly. So I can't go ahead explaining all this because this video is not about Ansible. So I will make another video dedicated to Ansible. If you want to learn more about Ansible, just comment below, I want to learn Ansible. I will make a video dedicated to explaining Ansible. So that's what you need. You just need this folder. This folder is for settings. The next file you're going to need is the Apache YML. So this YML file is called YAML or YML. So this YAML file is used to carry out configuration settings. That's what Ansible is. It's just about carrying out configuration automatically. Instead of you clicking button on AWS, you just use a YAML file and it will click all the buttons you would have clicked. So this is the host all just means that it should carry out these tasks. All these tasks listed there, it should carry out on all the hosts available. And then this become, okay, I won't explain every step because that will take a lot of time. So become means it should become a pseudo user, and these are the tasks. Ansible is quite simple. So these are the tasks that should be carried out by Ansible. Now this is update. Basically what this YAML file is just to install Apache and then create a landing page for me, a customized landing page. So this is the repo that is this is my repository, which I have a PHP file. Don't mind the HTML here. This repo contains a PHP landing page, but I want it to be displayed in a HTML format. So I'm going to tell Ansible to go to my repository and pick this HTML file, download it into my server that's going to be running on AWS, and then when it downloads it, it's going to put it in this particular location. It's going to replace HTML with my own configuration, and then it's going to run some other installation. It's going to convert my PHP landing file to a HTML. That's what this code says. That's what this code is doing, and then it's going to restart Apache. So at the end of this session, to confirm that your code actually works, we are going to visit the load balancer which we are going to create. We are going to visit the load balancer on a browser, and we should see my customized landing page on the load balancer. Now we are also going to need a backend. A backend in Terraform just means a container in the cloud that stores your Terraform files, your Terraform configurations, like your Terraform default files. That, you know, when Terraform works, it creates its own files. It creates like its storage, like a memory. Yeah, like let's say a temporary memory where it uses to remember what it has done. So when you run Terraform apply, Terraform plan, when you run all those Terraform commands, it has a memory that it used to know what it has run and what it has not run. So when you say go back, it can go back. When you say destroy, it can destroy. When you say create, it can create. When you say what are you creating, it can answer you. So it has a storage. Now that storage that it has, if it's not stored properly, your secrets, your confidential information can be exposed to anybody using your system. So we always use a backend to store it properly, so someone does not have access to the secrets that Terraform might expose on your laptop. So that's why a backend is important. Backend, everything, all the steps I'm going to carry out in this project is going to be standard practice. So you know how things are run in the normal settings, so you don't run into problem when you finally get employed or when you're working on a production project. This is just a practice. So that's why I'm using a backend, so that you can learn how to set up a backend and work with a backend. A backend just means an S3 bucket and a dynamodb. Now the dynamodb is going to save our statelock. Statelock is a file that Terraform creates, and the S3 bucket is going to also save our memory, Terraform memory files, Terraform state files. So when I run Terraform, I'm going to show you the files that are going to be stored in these two locations. Now dynamodb is used so that okay, you just Google what statelock is and you're going to know the importance why I'm creating both dynamodb and why I'm creating S3. Both of them work together hand in hand for Terraform to function properly. So you need the both of them. Don't just install one and ignore the other one. Now the next file you're going to use is and EC2. So I named it EC2 because I'm using AWS to run this project. You can use GCP or DigitalOcean or any other cloud platform, but I'm using AWS. So on AWS, a cloud computing server is called EC2. So the EC2, these are the configurations for the EC2. Now to create an EC2 using Terraform, it's a very short code. That's all. It's just about 21 lines. That's what you need. And I tagged it here, creating an AWS instance. And I'm calling that instance server 1. So you're going to use the resource block. In Terraform, we call this block when you define a resource. When you define a resource, and every other thing under it is called a block. So now this resource is like you're telling Terraform, okay, I'm talking about instances. Now when you're creating instance, name it this, and then when you're setting it up, do this particular task. That's what Terraform does. Terraform is just an automation tool that carries out commands automatically once you specify what it should do. So this AMI is gotten from so this AMI ID that you see here can be gotten from your AWS account. AMI just means Amazon image. So the Amazon image is Amazon machine image. That's AMI, Amazon machine image. So when you go to your instance, when you're creating an instance manually on your console, there's a part where you will see different AMIs. You can just pick the particular AMI you want to create and come here and paste it. That's how you get your AMI ID. And then your instance type is in my variable instance type. So these are variables. This is how this is how to declare a variable. Instead of just putting the raw figures, it's always preferable to use variables, because when you use variables, you can easily reuse this code without really going through everything. You just go to your I'll just come to my variables here. You can see the variables listed there. I just change anything I want, and then when I change anything I want, it reflects here. So if I want to change my key name, I just come here and change my key here, and then this is what will appear. Okay, so let's go back to EC2. Okay, I noticed a mistake. This is key name, copy. So I'm going to go to variable. This should not be key, this should be key name. Control V. So this should be key name. Okay. So now you notice that these things are not aligned. Even if I put this like this, even if I scatter all this, there's a command that I can use with Ansible to make it aligned again. So I'm going to scatter it on purpose. So when I run Terraform FMT, that's Terraform format, that's FMT. When I run that command, it's going to align this for me. So when you're working with Terraform, you don't really have to bother or trouble yourself about aligning just the way it was before. You can leave them scattered, then run Terraform FMT, and it makes your work look neater. So let's okay, now we are going to talk about hosted zone. Hosted zone is in AWS is a hosted zone is a service provided by AWS where you can create your own custom domain, link your custom domain which you already have to AWS. So when you have a load balancer, you can easily just link it to your custom domain. Let's say Roland any. So what I'm going to do, I have a custom domain here. Okay, domain name is var. Okay, let's go to variables. So domain name, I have roland.com. This domain does not exist, but you can put any domain that you have, any custom domain here, and then when you run this script, it creates a landing page for you. It creates a domain, a hosted zone. That's what it's called for you. So you go to your hosted zone and now link it manually. Terraform will not link it for you. But okay, we are not covering that. I think Terraform can link it, but I won't cover that in this particular video. Then this particular block of code is for creating hosted zone. These other parts are commented out because you don't need them right now. It's commented out because this is saying data.aws route. So this data this data block is only used when this data block is only used when the resource already exists. Let's say if I go to my AWS and create it manually. Let's open AWS. Let me connect to my internet. Open AWS. So let me log in so I can show you as we progress. I can show you what's going on. Okay, so this is the console, this AWS console. This is where you can carry out all those tasks I'm explaining. You can carry them out here manually, and this is my account. So I was talking about hosted zones. So if you want to create the hosted zone, this is where you come to. Okay, it's not here. You search for route 53. Okay, then you click route 53. This is if you're doing it manually, but this video is not about manual, so I'm just showing you for just to know the basics. So when you come to route 53, this is it, create hosted zone. So we are not going to do that manually. I'm just showing you that this is what my code is saying here, to create a hosted zone. So it's going to call the resource AWS route 53, and then it's going to create a zone called zone 1, and then it's going to name it my variable name, which I've already declared. Then this part that is commented is to use a hosted zone that already exists. So when you're using a hosted zone that already exists, you use the block data. So now this is to create a record. When I want to create a record, I'll have to create, I'm going to uncomment this after this has already run, when the zone already exists. If this zone does not exist and I run this code, there's going to be an error. So there's a sequence to this. So I'm going to run this first. I'm going to run the Terraform command once. I'm going to run the Terraform apply so that this can be created. Then I come back and uncomment this and run it again so that this resource will now be created. So let's go to the next. Okay, this is a bash script. A bash script is also an automation script, but is mainly for configuration and installations and updates. So that's what this is. A bash script is just for it's just for practice. I'm not going to really use it. I just want to show you what a bash script looks like, because there are different ways to run installation on installations on an EC2. So there are 3 ways to run installation on an EC2. The first way is by bash script. Let me go back to EC2. So this line, I forgot to explain this line. This line called user data is a shell terminal. It's a predefined terminal that is created by AWS, where you can write shell commands. So these shell commands will be carried out immediately your instance has been created. That's if you want some pre-installed packages on your instance, that once it comes up, these packages should be already installed. You use the user data. So you can use the user data to tell AWS that it should do this particular task for me while it's setting up my EC2. So all this is saying is just sudo apt upgrade, sudo apt install apache, sudo apt. All these are just simple commands that I want to be already done on my EC2 before it is even prepared for me to use. So that's what the user data is. You can just set commands that you want to be carried out on your EC2 before it is being set up. So that's one way. Now the other way is by using a bash script. So if your command is a lot like this, or if you just want to write it and add it as a file, you can also use a bash script and save it. You know, the extension for a bash script is .sh. So when you save it with a bash script like this and you put your .sh and you drop it here, Terraform already recognizes it as a bash script. So the way to link it and tell Terraform, okay, this is the part where you used my bash script, you use the user data. So if I was going to use the bash script, I'm not using it, so that's why I'm going to put it as a comment. So if I'm going to use the bash script, I'm going to say user data is equals to file, then I'm going to put bracket, and I'm going to put this, and I'm going to say Jenkins. I'm going to say Jenkins server.sh. Okay, so if I was going to use user data to run this script, this is how I'm going to tell a Terraform about it. I'm going to use the user data and tell it that, okay, when you're creating my EC2 instance, I want you to pick up this bash script and run it in the background of this EC2. Just run this command, run this configuration, make my EC2 to have these packages already pre-installed before I now work on it or deploy anything I want to deploy on my EC2. So this is how to use a bash script to run configurations on your EC2. So I'm going to leave that because leaving this won't affect my script. I'm just going to leave this here, and then I'm going to go to hosted zone. Okay, I've explained hosted zone. Now LB is load balancer. So I'm going to create a load balancer because I'm not creating one instance. You can run a Terraform script to create more than one instance. Like here, I forgot to explain this line that says count. So count 4 just means it should create 4 instances, but I don't want 4. I'm going to make it 2. For you to use a load balancer, you need at least 2 instances, 2 or more. It can be 10, it could be 5, it could be 7, it could be any type of number, but I just want to use 2, so my Terraform will not run for too long. So when I run the Terraform apply, after a short period of time, it finishes orchestrating what I want. So this command, this count, is used to specify how many instances you want to create. So I'm going to use 2 here, and then this load balancer is going to be linked to the instances. So these are my availability zones, and this is the name of my load balancer, LB balancer. This is my listener, and this is the health check block. So you just need this whole block for it. So that is just a one block to create a load balancer. This elastic load balancer. And then instances. Okay, this is how to connect your instance to it. So ELB attachment, I'm specifying that the instances I want to connect to this load balancer is the one called AWS server 1. Then this ID, I'm using the wildcard because I'm creating more than one instance. So you use this wildcard, that's the asterisk sign, to specify that it's more than one instance that you want to link. You want to link a series of instances, so you use this and you say ID. So it's going to pick those server ID and link it to this load balancer. So server 1, can you see AWS server 1? So this is what I was specifying, that the load balancer should be connected to this resource. And now output. This output is used to create okay, let's look at this line by line. So this first line is to create this is to tell Terraform that after creating the load balancer, it should display it as an output. That's on my terminal. Once I finish running this Terraform script, I'm going to see my load balancer DNS. So I'm not even going to need to go to AWS to do anything. Nothing concerns me on AWS console. I'm going to be running everything locally on my laptop. So once I run this script, I will get my load balancer DNS right on my terminal. So I'll just copy it and visit it on my browser, and that's all. Then the next line is to create a file. This file I'm creating is where I want my EC2 public IPs to be pasted, or to be stored. So I'm creating a file called host inventory, and that file is going to be created right in this folder. So when I run Ansible, it's going to create a file for me that will be here, and then it's going to cut all this IP address. This line is just saying that it should pick the IP address of my instances which I've created, my public IP address, and it should save them in that file called host inventory. And then when I'm running my Ansible script, it's going to use that host inventory to talk to, Ansible needs a host inventory file. That's where your public IP will be stored. So it's going to use that host inventory which Terraform have created. It's going to pick those public IP inside that file and then run Ansible on it. So I just hope I'm clear enough. So now this line I told you is just to create a file called host inventory and to store public IP addresses inside. That's you can see I'm using the asterisk again because it's not one public IP address I want to store. I want to store like a multiple public IP address. So I used this. Now this EOT is used to I'm using it to attach Ansible command to my Terraform. So I'm saying while you are running this Terraform, this provisioner local exec, that's I'm telling it that you should run this locally. That's local exec, that's like local execution. Now this is the command I want to run. This is the same command that I can run for an Ansible script right from my terminal. So that exact command that I'll run for my Ansible script on my terminal, I just paste it there. This is how to run an Ansible script by saying Ansible playbook. Then you specify what the playbook is called. That's Apache YAML. I already have it here. Yeah, I already have it here. And then I is just interactive host inventory. So host inventory is later going to be created right here. Then the next thing, these are just basic Ansible commands. And then my private key is stored in my home. So I did not put my private key here. You have to take note never to put your private key in your GitHub repository, because once you put your private key in this particular folder, you might not know when you push it to your GitHub. And once you push your private key to your GitHub, someone can take hold of it and make use of your AWS account in your without your permission. So you have to be aware of that. It's very risky and it's a security threat to upload your private key to GitHub. So that is why I did not put it here. I left it on my local machine. It's in my home directory in my local machine. So it's going to pick that file. It's going to pick my private key from there and connect to AWS. This particular key that I'm referring to, I downloaded it from AWS. If you don't know how to get your private key, you can watch my YouTube playlist about AWS, how to create an instance. You understand how to get this private key and how to properly use it. I have a video on that on my channel. Feel free to check on it and watch it and understand more about AWS. Now, okay, I told you that this command is to connect the Ansible script to Terraform. That's all. This short line of code, that's just it. Then next is provider. This provider block is very, very necessary. One of the most important block is just this line. Some provider block can be more than this, but I like to use this particular one because it makes, when I use the other long version that specifies the version and a lot of specifications, I run into error. So I don't specify much details. I just use this block so that it runs automatically, it synchronizes, because there are different provider versions. But I did not specify my version here and it still works smoothly. This part of my code that is commented is for my backend. So when my backend is already running, I can now uncomment this and tell Terraform that I have a backend running. Now let's use the backend. If I uncomment this now, Terraform is going to tell me that sorry, this backend does not exist. I don't know what you're talking about. So that's why it's commented. When I created this file creates the S3. This other block creates dynamodb. So when it's created, I'm going to comment this out, then come to this part, provider, and then I'm going to uncomment this, then run Terraform apply or Terraform initialize. Once I run that, it's going to recognize, okay, now I have a backend, time to connect you. So I'm going to take you through the process, so don't be scared, don't be confused, just follow me step by step. Okay, so now this is my readme file. You're going to find it on my GitHub repository. It just explains what I'm doing now and in text format. Now SG is my security group. So this is a basic security group. I did not really specify. You can replace your CEDAR block with what you want. So this CEDAR block just means everybody, anywhere, the whole internet. But you can make it private by specifying the IP address that you want to create, the CEDAR block you want to create. So that's what this security group is. Very simple. You can use it exactly as it is, or you can tweak it a little to your own satisfaction. Now, terraform.tf.vars, this is a folder that you use to store your variables. So this folder is used to store variables, just like declaring variables. All these are just variables which I've already used in different files here. Don't worry that these files are scattered. This one can be above this one can be below this. Terraform knows which to pick and which to run. So don't be bothered and say, oh, this backend is above EC2 or EC2 is above backend. Don't worry, it's okay like this. And this is the best way to run Terraform using each file. You can actually compile everything and put in a single file called main.tf or something like that, but just like you run Ansible, but it's better for you to do it like this, so it can be reusable. Someone can easily understand, okay, this is what this code does, this is what this code does, this is what. If I put everything in one block, some people might get confused, it could be clumsy. So you can actually put them together, or you can use them separately like this, which is the best recommended way. Now these are my variables, which are very easy to understand, and then this is another variable. So you can either use this to define variables or use this to define variables. I use the both of them so you can know how both of them work. So this ones, when I call this variable, I did not define anything in it, I left it empty. So if you leave it empty like this, it's going to prompt you that, oh, you've not defined this. You can actually define it just like I defined here. You can see this is the proper way to define a variable if you're going to use only variables.tf. But I'm using both of them. So in this so in this file, I'm defining my variable, and then in this file I'm also defining it explicitly. If I only use this, it's not going to work. If I only use this, it's not going to work. So you have to use both of them, or then use this properly by defining it like this, or use this properly by defining it like this. So that's the two ways to define variables. Then my VPC block, this is just to create your own private network. Everything is you can just use it exactly as it is. This to create my subnet, this to create my internet gateway. As you can see, IGW is internet gateway, and this to create my my main gateway, internet gateway, and we are good to go. So once you have this folder, you clone this folder, you have it on your system, then you're good to go and follow me in my hands-on tutorials. Now check my next video for part 2, where we are going to do the where we are going to carry out the hands-on. I don't want the video to be too long, so I'm making it in 2 parts. This is the first part, just fundamental, knowing what we are going to do. These are the tasks we are going to be carrying out to set up our environment. These are the requirements, and these are the tasks. So in my next video, I'm going to show you how to set up the environment, and then I'm going to show you how to carry out these tasks. Thank you, and check for my next video.